Guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have x squared plus x squared is equal to x to the power of 4. Now what I'm first going to do is I'm going to subtract x to the power of 4 on both sides. So now we have x squared plus x squared is equal to, minus x to the power of 4 is equal to 0. Now what I'm going to do is I'm going to factor out the greatest common factor of all these terms, which is actually x squared. So now we have x squared times x squared divided by x squared is 1 plus x squared divided by x squared is 1 minus x to the power of 4 divided by x squared. Well, if we have something in the form a to the power of m over a to the power of n, this is equal to a to the power of m minus n. So x to the power of 4 over x to the power of 2, that's x to the power of 4 minus 2, and 4 minus 2 is 2, so this would be x squared. And this is equal to 0. Now 1 plus 1 is 2, so now we have x squared times 2 minus x squared equal to 0. And now this gives us two equations. Our first equation is x squared is equal to 0, and our second equation is 2 minus x squared is equal to 0. Now for x squared equals 0, well, this is simple. The only number that's squared is that equals 0 is simply just 0. So for this, we have x is equal to 0. That is one solution. Now for a second equation, I'm going to add x squared on both sides. So now we get 2 is equal to x squared. And now if I take the square root on both sides, I get plus or minus the square root of 2 is equal to x. So these are two more solutions to this equation. Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 6 to the power of x is equal to 9. Now what I'm first going to do is I'm going to take the log of both sides. So we have log of 6 to the power of x is equal to log 9. Now, if we have a logarithm in the form log a to the power of b, an important property of logarithms, also known as the power property, states that we can actually move this exponent to the front of the logarithm. So this would be equal to b times log a. So now I'm going to do the same exact thing to log 6 to the power of x. Now we can think of 6 as a and x as b. So I'm going to rewrite this by moving the x to the front of the logarithm. So now this would equal x times log 6 is equal to log 9. Now, to isolate x, I'm going to divide both sides by log 6 so that we can move log 6 to the other side. So now we have x times log 6 divided by log 6 is equal to log 9 divided by log 6. Now, for our left-hand side, these two cancel out, and we simply have x is equal to log 9 divided by log 6. However, if we have a logarithm in the form log a over log b, this is also equal to log base b of a. So we can think of 9 as a and 6 as b, meaning x would equal log base 6 of 9. So this is our answer.